Today we are going to solve this problem, n queens. So the n queen puzzle is a problem to place n queens on multiple n chessboard, such that no two queens attack each other. Given integer n, return all distinct solutions to n queens puzzles. Each solution contains a distinct board configuration of the n queens placement, where Q and dot both indicate a queen and an empty space. For example, if the input is 4, we are supposed to return these two distinct placement. And okay, so the input is only the integer n, and the output will be a list of list string. The list of string is individual result like this one. It contains different strings, and if have more than one result, it will have multiple list. So the basic idea is to try every single row. For example, I will write the backtracking function to check each row. If the row reach to n, it means the current board is one solution, and we find one solution. In each row, we are trying to place the queen in each columns. For example, here, let's see here. Choose which one? Like this one. If we want to place the queen in this column, and we need to check all the columns, if the previous rows columns, if they can attack each other, and also the upper left, the diagonal, if they have any queens, and the upper left, the anti-diagonal line, if they have any queens. If these things, if we pass the 3 check, we can try to place the queen here and go to the next rows, and eventually it is a backtracking problem. So in this case, in this way, we can find all the possibility solutions to the n queens. Let's try to code up. So first, we need a place to collect the result for us. And now we build the board. We initial everything is the dot, it's empty board. So it's empty board. In each row, repeat n times, and we need to add the n rows to our board. Now we have the board. The next step is to do the DFS from the first row up to this one. We can return the result. The DFS will contain a board and the row here. If the row ends to the last one, which means the current board is a validated board. Okay, this is a good case. If not, we are trying to place all the columns. here. Okay, and we will try all the columns. First, we need to check if it's valid to place this one in this board, the row and the column. If it's not valid, we will continue to try next one. If we pass this one, I will implement later. Now we will do the backtracking place. So we will get this rows string to char array, and then modify these columns to queue, the DFS to the next row. Okay, we need to set the board this row to the new columns. This is the DFS part. So if we back to this layer, we need to undo the choice we did, like this one, return to dot, and set the board, the row to the previous row. After that, we can iterate. We can traverse all the valid cases. Now we can start to implement this valid function. We are given the board. What's going on here? Okay, something wrong. We needed to undo this one to the dot and set this row to the previous columns. Okay, now we are how to validation we have the row and the columns, how we can make sure we can place the queen here. For example, like this queen I can place here. We have the size, so for each previous rows, if the get at that row and the column at this column it's equal to Q, which means like this one, if we place here the previous rows, this column is already have a queen, we cannot place here. So in this case we need to return false. Also now we are to check the for this one, it's check this orange ones. So the previous row and the column will be the column plus one. If they are valid in the inside this board, and each time I will go row will be smaller, column will be bigger. In this case, if the board at that row and in that column it's already have some queens, I need to directly return false. Okay. Similarly, we need to check the left part, upper lefter. The column also will be smaller. They need to inside this board. they both decrement. Okay, if the board at that row and at that column have the queen, we cannot place it there. And if we pass everything, I can return true here. Okay, let's try to write. Cannot find symbol. Typo here. Okay, it seems works. Let me submit. Yes, it works. The basic idea is to, as we mentioned before, to try each row, and in this DFS function, we try each columns. Try to place the columns into this position. If it passed, it's valid. How to identify valid? We check the each previous rows if this column have any queens, and the upper left if any queens, and the upper right if any queens. If these three passed, it means we can place the queen in this position. So we update the board, pass this current board to the next row to do the backtracking for us. Then we return to this row. We need to undo the choice, which means we need to set the current position to the empty space, to the dot, and set the board to that state. After that, we collect all the data, all the results, and that's the end queens. To the time and the space complexity, if we don't encounter the final result, we construct a board to represent the chess. If that count to the additional space, it will be O of n square, because we have only n input, and the time complexity will be exponential, because we will try each cells once. Each cells we need to try each cells, so it's including the choose or not choose. Let's double check with the answer here. So our approach is backtracking. Okay, here they are using hash set to check the duplicate. Contains add queen. Okay, the time complexity will be n factorial. Space is n square. Build each validation. So the time complexity will be n factorial. Square that. Okay, I think that's it.